So as you might know, a week ago, and let's say 10 days ago, we deployed a new Jupyterhub at DKRZ, and we thought that we can use this opportunity to introduce the new release. So hello everyone, thank you for your interest. Thank you for watching now or later since the video is recorded. My name is Sofiane Bendoukha for the pronunciation, and the focus today will be on Jupyterhub. And I think there will be more interesting talks and hands-ons related to Jupyter in the future and dealing with use cases or software packages. So I'm going to skip this slide, but yeah, I think Florian said everything about myself, and yeah, it's worth mentioning it's not the real cloud in my PhD, but it was about cloud computing, and I'm also currently working on the containers. So let's start with the short introduction. So we will see our motivation on how on why using Jupyter Notebooks and why we were thinking about the new Jupyterhub instance at the DKRZ. So the popularity of Jupyter among researchers or data scientists is strongly related to Python. So even if one can use different languages, so this, for example, this slide shows the ranking of Python and its progress. So we can see clearly how Python progressed over the years. So this ranking was from actually from last month. So for data scientists, Jupyter has emerged as the de facto standard when working interactively with Python. So it was released in 2014. Jupyter Notebook is an open source web application for creating reproducible computational text or narratives. So this is a document that can contain live code, equations, or narrative text, visualization, or rich media. So it can be easily shared with other colleagues or with other researchers. So you can convert your notebook into different format, for example, PDF or HTML. So the working environment of a Jupyter Notebook includes in-browser terminal, file browsing section, and it can support many languages actually, not only Python, but for example, R, Julia, or C++. And it has an extensible design, so thanks to the many server client plugins. On the left side of this slide, so you can see the architecture of a Jupyter Notebook interface. So then you can see the notebook server, which is responsible for saving and loading notebooks. And the kernel just gets sent cells of code when the user runs them and send results back. So if you can run easily a notebook on your local laptop, you just install, for example, Anaconda, and you can install the Jupyter Notebooks package, and you can start working. So, however, in order to run notebooks on a remote shared resource like our Mistral HPC, so some additional steps are involved. So one would need, for example, to log in to the HPC cluster, use command line to reserve computing resources, and set up some SSH tunneling. So the complexity of an HPC environment may include other steps related to some security setups or mounting, loading directories from shared file system. So this just shows some steps to start, for example, a notebook on an HPC. So, but the more convenient way to run notebooks on a shared resource or shared server is using Jupyterhub. So it can save time and provide some abstractions level to the users. So at the DKRZ, we provide, of course, the Jupyterhub server, which is user-friendly. So we have nice, you only need a browser, and it has like a nice graphical user interface. And we also provide the full user support. So there is a complete monitoring system running in the background, so we can see if something is not running correctly, actually. And we are continuously working on new features, implementing new services, and updating some packages related to the Jupyterhub software. Furthermore, we have also a script to start single Jupyter notebooks that can be downloaded on our website. If you see limited support, it does not mean we don't provide any support for that, but it just means that most of the errors or the issues within the script are on the client side, and we are really not always able to debug something on your laptop. And this is what I mean by limited support, but you can always contact us if you have problems with that. It's also related to which operating system are you using, and it has sometimes a networking problem. Uh, Another issue, possible issue that with the script is the port forwarding. So if you run one server, it's okay. You can just like uh, forward that port. But in some cases, let's say that you want to start many server. Uh, with the Jupyter Notebook, in this case, it can be really annoying. And a good example for that, for example, is the task dashboard. And if you really see the Jupyterhub Advanced Spawner, so which will be presented later, so this is exactly what the script is doing, but in a better way. But you can do everything on using an options form, and then you can play on these learn parameters and also on the Jupyter interface. So this slide only shows some progress events. So at the DKRZ, we already had Jupyterhub server, which was running really quite well, and also after that we provided the script for that. And in the end of 2019, so it was decided that we have to bring more features and make like an upgrade and based on the user requirements. But and in the beginning it was a little bit hard to work on the same machine, so we just decided to start from the scratch. And now the new Jupyter Hub has its own machine, and yeah, and let's say virtual machines. So last March, so we released the first beta version, and then we informed some of our users. So thank you very much for your feedback. And after that, we were so maintaining, doing some maintenance, updating some packages, fixing some bugs. And last month in August, so we pushed it to the production. And yeah, in the end, so if you maybe you already know that we have a new system coming, so that will be the next major release for Jupyterhub. So of course we had to do some refinements to adapt the current server to the new system. So what's new actually in the new release? So in this figure you can see that the most important part or component is the DKRZ spawner. So this piece of code is responsible for the whole life cycle of your notebook on Mistral. So from the options form to allocating resources to your notebook, starting the notebook, or starting or stopping, and then making the tunnels to your browser. And also we enable the Jupyter Notebook extensions, and we have a new front end. We worked on we customized the login page, for example, and other pages. And we also enabled own user Python environment. So it is possible that you use your own Python environment as a kernel in the Jupyter Notebook. And we have different spawner options. And for some projects, we also included new profiles. And we have also integrated some services which are running on the background, and that helps our user to get an overview about their account, information about the quality of service and available partitions and features or constraints. So in general, a Jupyterhub server is composed of many. It's modular, so you have many components, and the role of these components is to manage authentication, how the users log in, log out from the server, and it spawns single-user notebook servers on demand, and give each user a complete isolated server. So this is how a Jupyterhub works. On Mistral, it's a little bit different. So on Mistral, this is how it works. So you log in, or you use your browser to log in to the login. So Jupyter Hub server, and then you choose which spawner options. And once you enter the required information, and now it will be the role of the DKRZ spawner. It will take care using the Slurm workload manager to find the available resources, allocate the resources, for example, CPUs, memory, and time. And after that, it will start the notebook on one of our available partitions, shared, pre-post, or compute. And then you can it sends the page or the notebook back to your browser. So this is how it works. Let's say it's behind the scenes. So as I said, we have a new front end. This is, for example, the login page, and my idea was to try to include all useful information that you need to start your notebook. So let's say that we have many links related to how to create your account. Maybe you forget your password, and we have some links on to the Jupyterhub documentation, and also Mistral configuration, and some Slurms tutorials. Yeah. I'm sorry if you don't like the color of the login page, but we can change it if you want. We have also some managed services. So on the top of the menu, so you have a services tab. So when you click on it, so you have two services. So one is mostly for administrators, so we can write some so Jupyter Notebook has its own announcement service, so we can write for example, when we are doing some upgrade or the server is down. And on the right side, you have also the account service. So I'm still improving this service. So for now, it can give you the most useful information about your account. So this is actually Slurm's account. It means the accounts where you can submit Slurm jobs. So, and it also shows the available partitions and the corresponding constraints or features. This is mostly useful when you use the advanced spawner. Now we have a new documentation for Jupyterhub. It's written with Sphinx, but it will move or will be merged one day to user portal. So it will not be like separated from our user portal documentation. But I'm trying to keep this updated. And for example, I'm trying to add more information on the tutorial side. But any input is welcome. I mean, if you see that an information is useful for other users, so you can just contact us, or maybe an information is wrong, and maybe because uh, the Python environment is really changing every day, but sometimes tutorials is not working. So feel free to contact us, or if you have any feedback on the documentation. So actually, I just changed the template for that last week. So one more thing, Jupyter Lab is available for both spawners, so preset or advanced. It is even possible to use options form to choose between the interfaces when you start your session. Uh, Switching between the interfaces is possible and very easy, as actually you just need to modify the URL. So for example, this animation shows how to switch from classic Jupyter to Jupyter Lab and vice versa. So just be careful if you want to go back to mention the correct path to your home. Okay, that was an introduction. So now we are going to see the three main, let's say, new feature in this release. So we will be talking in details about the spawning process or spawning options. We will talk about kernels and extensions. So let's start with the spawner options. So once you log in into Jupyterhub, there are two tabs where you can choose between preset or advanced options form. These are two different spawners. These are two different pieces of code related to the DKRZ spawner to customize your session. So this means what are the resources that will be allocated to your Jupyter Notebook, so memory, CPUs, and time. So in the preset form on the left side, so we already configured some profiles with the most important Slurm options, cores, memory, and time, for example. And in the right side, you see the available profiles. So depending on what you want to do, just pick the one you think it fits your requirements. So for example, the shared partition is for small developments or testing projects. And the pre-post is quite similar, but it can also, but it allows X outside of Mistral, because in some cases or in for some libraries, so you need internet to download some maps, and in this case you need internet, and not all our partition has access to the outside world. The other fields are not mandatory, so you can leave them as, I mean, the reservation and the quality of service are not mandatory. So only the profile and an account is necessary. So if you ask about the, for example, the quality of service, so we use it mostly when we have like workshops or training sessions. So sometimes we assign Slurm job to a high priority in a Slurm workload manager. So that was the preset options form. And yeah, for advanced users, we have the advanced spawner options. So these options form allows you to customize many parameters. For example, you can choose which Jupyter interface to start with, classic Jupyter or Jupyter Lab, and you can also modify many of these of Slurm parameters. So, and yeah, you can also rename or name the log file, and yeah. So this table just shows the parameters and their descriptions, and this is also available in the documentation. You can just take a look there and to see the, let's say, the definition of each parameters. Most of the errors that you might see with the advanced spawner are due to misconfiguration of the Slurm parameters. So in this case, you will see something like this. So SPatch error. For some fields, there is an information about the origin of the error. For example, you enter a wrong value for the number of cores or memory. In that case, you will see the origin of the error. But for the other fields, I suggest that you take a look first at the Mistral configuration page. So I added the link here, and there you will find the you will see the available partitions and their resources. So you will see that how many cores can I find in the shared partition, for example. So it's worth to take a look there before you use the advanced options form. So the named server are not a new feature in our deployment, but a new feature in the Jupyterhub software itself. So, and this is what allow us to have more than one server running in the same time. So currently we have two allowed, preset and advanced, but we can have more. So, for example, with the coming system, maybe we require a new spawner, so we will just add it in a tab as an options form. So it's very flexible, and we can also decide how many servers the users are allowed to run in the same time. Um, Locking out or closing your browser won't stop your session automatically. Your notebook is running as a Slurm job, as you know. So if you finish your work, you need to explicitly stop the server. So otherwise, it will continue consuming the allocated resources. As you can see in this animation, stopping the server depends on how you started in the beginning, preset or advanced, and also depends on the interface, Jupyter Lab or the classic Jupyter. They have different functions how you stop your Jupyter Notebook. So that was the spawner options part, and now we are going to talk about the kernels. So the kernel is the most important part in a Jupyter Notebook. It's the compute engine of the Jupyter Notebook. So it accepts messages, performs actions, and sends out results. I will not give more details on this slide. This is just a sequence diagram that show us what the communication process between the most important parts of a Jupyter Notebook. So concretely, it shows the interaction between the browser, the notebook server, and the kernel when the user just types something in a cell. But this is happening in the background, so you don't have to worry about this. So on Mistral, we have various kernels automatically installed. So when I mean system, it means that you are not you cannot change the content of these modules or kernels or install new packages. So probably we are going to remove the Python 2 kernels because starting 2020, Python 2.7 or Python 2 is no longer maintained. So the most recent module can also be accessed via the shortcut Python 3 and stable. And I recommend all our users to use this module. So in the coming weeks, I will also add more Python system Python kernels. And as I wrote here in the bottom, so we will have a new Python about every half year. And the first one is this one, the Python 3 2022, and the compiler version. So at the moment, I think we have only one Python, but there is a next module coming in the future. So I recommend that you will use this module because this kernel, because it contains the latest versions of all the Python, of the installed Python packages. If you have your own Python environment, so depending on how it's installed, it may just show up in the list of kernels you can use. So if not, so use the following procedure. So it is also documented. You can find it on the documentations on the kernels section. So to enable a custom kernel based on Conda or virtual env environment, so you just need to restart your session after you do all these steps. There are some good practices when you want to use your own Python environment is where you will install it. I mean, maybe you already know that the content of your Conda environment, it can blow up and everything is stored in your home directory. Maybe it is better to install it somewhere else, maybe in the project directory or something. This is just some best practices. Otherwise, you can just create your Conda environment in your home directory. Also for the configuration, I mean, let's say that you need additional executables. I mean, you created an Python environment. It's working fine as a kernel, but sometimes you need some external, let's say, libraries outside your kernel. So in this case, it's possible to customize your new installed kernel by extending the kernel specification file. So this file is generated when you install the kernel, and generally in local shared Jupyter. And yeah, there are other tricks and to optimize this process, which are described in the documentation. So for example, you can use an executable script. So you create a script and you put all instructions that you need, for example, loading some modules or exporting some environment variables, and then you put it as a parameter into the argument in the kernel specification file. Um, this is just how you can use or change the kernels for Jupyter Lab. All available kernels, including the one you just created, for example, are on the right side. You can just directly click on one of them and it will start the notebook with the corresponding kernel. So changing kernel, you click on the menu kernel, change kernel, and select the one you need. This is for Jupyter Lab. For the classic Jupyter, it's almost the same thing. When you want to change the kernel, the difference is only when you want to create a new one. There is a button, new, and then you choose between the available kernels. I put this here because, yeah, when you launch Jupyter Notebooks on Mistral, the logs are saved files in your home directory. So, yeah, these logs can be very helpful when it comes to debugging issues with Jupyter, so your custom kernel or your Python environments. So the name of the log file is related to the spawner options form you need. So you used in the beginning, so presets or advanced. It will take the name of the spawner. It just make it easier to, to trace the errors. You can actually control the verbosity or logging level. There is a configuration file called Jupyter Notebook config, and actually you can change the level of the logs there. It's in your home directory. If you still have problems, of course, you can contact us and then we can figure this out together. So the last point is the Jupyter Notebook extensions. So extensions are a kind of add-ons to extend the basic environment or the design of a Jupyter Notebook. So for this release, so we included the extensions configurator, so in the root environment. So when you open your notebook, the classical one, so you have this tab MB extension, so you can see some of the notebook extensions and you can enable or disable them. Uh, and of course, you can do all this using the command line. And yeah, you just need to mention the correct path of the, sometimes it's only the name, and you can enable or disable the Jupyter Notebook extensions. In the root environment, so we already installed some let's say useful extensions. So for example, I noticed that many of our users are experimenting with Dask library and Dask clusters. So I added this Dask Lab extension. This is an awesome tool to help you both visualize your Dask cluster and to see what is really happening there. So and using Jupyterhub, so you don't have to care about any networking because it's in the same network. So you don't need any port forwarding or SSH or yeah, something like this. Also, this was like a request from one of our users. I don't have much information about this. I just have the definition. This app mode extensions. It turns notebook into web applications. So you can take a look there. And if you need it, you can just use it. It's already installed, and you can disable it or enable it, of course, when you start your notebook. There are more extensions, but as the Jupyter Lab developer said, that we cannot review all third-party extensions due to security reason. We cannot just install all available, and it will really slow down the server. But if you really think that you need this extension in your work, so just contact us and we will see. The problem with the extensions are mostly need the server client. So this is why we need to install in the root environment of Jupyterhub. This is why sometimes we try to avoid it. But as I said, if you need an extension, just check if maybe you don't need a server extension for that. So you just install it in your user directory. Otherwise, you just contact us. Yeah, I think this was the last point, and this slide only shows the things that we are working on or thinking about how to improve the existing features. Actually, we are thinking to provide some sharing services. We already talked with some of our users, and in the past we have concrete solutions for that, but we need to talk to our users first before providing those kind of services. Actually, this is a good way to share your, let's say, notebooks or code with other researchers, and the idea is that we can restrict these sharing services to private or shared, or even use external sharing services. It's like Dropbox like services. And yeah, we are going to allocate the Jupyterhub's jobs to a high spawning queue in Slurm. So it might so speed up a little bit starting the notebooks. And we are thinking to add some dedicated system kernels or extensions just to separate the use cases, for example, machine learning or CMIP6 kernels. And uh, currently, there are some users complaining about the Jupyterhub or Python being slow on Mistral. Actually, the problem does not come from the Jupyterhub server itself, but where the modules are loaded from. There is some specific uh, mounting point on Mistral, and we are aware of that already, and we are working on a better solution to make loading Python more faster. And one of these solutions that we are working on is the use of containers. So we use it in different projects, but we are going to start experimenting, and we will see if it brings something. So the last point, maybe some of you already know about binders. So I have been using this the last 3 years for, let's say, learning purposes, and but maybe you know that the problem with those services is where can I get the data? So if you have to download data to your notebook, so this is not a good idea. So maybe we can offer or provide a binder for Mistral, so you have access to the data pools from Mistral. I think that's all from my side. So if you have any feedback or questions, and you just write in the Google Doc, and back to you, Florian.